Okay, I'm just testing the sound on this feedback to make sure that it's recording okay. Hello, thank you for taking the time to watch this video. I'm going to go through using Pythagoras' theorem assessment task, question by question, to make sure you see where the marks come from and how to answer each of the questions fully. I'll be picking up on some of the classic mistakes and some of the common misunderstandings that mean the next time you see exam questions like these, you'll pick up all the marks. That's the plan. So, question number 1. The parallelogram ABCD is drawn on the centimetre square grid. This is a parallelogram. It's important because later on in the assessment you're asked to identify a parallelogram, so you can use the information already given to you in this question to help you answer some of the questions later on. In this shape, the coordinates of A are -2, 2. So I'm going to check, there's A, look. So what does the -2 and 2 mean? Well, it means it goes back 2 and up 2. And if you check that in your exam question, then that will help you to answer the next 3 coordinates. So coordinate B is here, that's 3 across and 2 up. 3, 2. Coordinate C is here, that's 2 across and 2 down. 2 and -2 because it's down. And D, back 3, down 2. Back 3 means -3, down 2 means -2. You'll notice there are 2 marks for that. You get 1 mark for 2 correct coordinates and 2 marks for all 3. Now Emma says the perimeter of this parallelogram is more than 18 centimetres. How do we know she's correct? Well, perimeter means the distance right the way around the outside. So what is the distance all the way around the outside of this shape? So we've got 1, 2, 3, 4, 5 squares across the top. 1, 2, 3, 4, 5 squares across the bottom. So that's 10 squares there and there. Now these sides go through 4 squares, but they're not 4 centimetres long. They're actually longer than 4 centimetres long. So if this was the 4 centimetres, the 4 squares, then this diagonal is going to be more than 4. So why is Emma correct? We know Emma is correct because the diagonals are more than 4 centimetres. That's the key piece of information we're looking for in order to pick up this mark. And finally, how do we calculate the area of the parallelogram? Well, we know a parallelogram is effectively a pushed over rectangle. They have very similar properties, and we find the area of a parallelogram in exactly the same way as we do the area of a rectangle. So it's the length times by the width, or in this case the height. So for our parallelogram up here, it's 5 long and it's 4 high, which means the area is 20 centimetres squared. Just to show you how that works, that triangle there is exactly the same as the bit that's missing here. So if we were to cut that off and put it here, we'd end up with a rectangle. Area of a parallelogram, exactly the same as the area of a rectangle. 2 marks. Question 2. 2 sides of a parallelogram are drawn below. Write down the coordinates of point A. 3 across, 4 up. 1 mark. Write down the coordinates of point C. 3 back, 3 down. Just take care here to make sure that you've got negative coordinates because it's back and it's down. 1 mark for each of those. Part C, draw 2 lines to complete the parallelogram. So this is the start of our parallelogram. We know, because we've seen in question 1, a parallelogram is a pushed over rectangle using a ruler and a pencil. 2 lines should look like that. 1 mark for correctly drawing the parallelogram, and you need to write down the coordinates of point D. So D is this one, the missing point. How do we get there? We need to go back 3, and we don't go up or down at all. So it's back 3, and the y coordinate is 0. 1 mark. Okay? Question 3. We'll have to keep flicking back to this diagram because we're on the other side, but we have line AB, and the first part of the question asks us simply to mark on the line the midpoint. So mark the midpoint of AB, label it M. So here it is. Here's our line AB. The midpoint, as you know, is the middle part of the line, the middle point of the line, and we're labelling that M. The second part of the question asks us to identify the coordinates of M, so that's 4 across and 2 up. 4 across and 2 up. It's 1 for drawing the midpoint and 1 for writing down the coordinates. Now we need to draw a line through P parallel to the line AB. Let's have a look at that. Here is P, here is our line AB, and what does parallel mean? Well, train tracks are parallel. It's 2 lines that never touch. There we go. So I need to draw a line that is always the same distance away from AB. Should end up with a line that looks like this. So if it's exactly the same distance away all the time, it's never going to meet. Therefore those 2 lines are parallel. Get 1 mark for that. Question 4, the diagram shows the positions of A, -2, 5, and B, 4, 1. Find the coordinates of M, the midpoint of the line AB. So here is AB. The midpoint of the line is here. Midpoint. The coordinates are 1 across, 3 up. 1, 3. And in this case there are 2 marks for that question. At this stage, if you feel you need any additional help with finding the midpoint of a line, a good thing to have a look at is clip number 78 in Maths Watch, finding the midpoint of a line. Okay? And finally, question 5. Although we're still looking at coordinates, we're now asked to calculate the distance between A and B. And to find the distance between A and B, we need to first work out what's the difference in the x coordinate. 1, 2, 3, 4, 5, 6, 7, 8, 9 across. You could work that out from the coordinates themselves. Going from 1 to 10, it's gone across 9. Going from 3 to 5, it's gone up 2. So we now have a right-angled triangle. With a right-angled triangle, we've got the shorter sides, and we're trying to find the long side. And we know from Pythagoras' theorem that the square of the 2 shorter sides add up to make the square of the longest side. 2 squared and 9 squared, there are 2 short sides, add up to make the longest side. So that's 4 plus 81 gives you our big square, which means the big square must be 85, and we need to find the inverse of that square number. So inverse or square root of 85, which equals 9.2. 9.2 units. And you'll see 5 marks for that question. If at this stage you still feel you need to practice Pythagoras' theorem, then my suggestion would be to go to MathsWatch and look at these 2 clips. Clip 118 to practice using the theorem to find the longest side and shortest side of triangles, or clip 119 to find the distance between 2 points on a graph. Hope you found this useful, and thank you for taking the time to go through it. If at this stage you still feel you need to practice Pythagoras' theorem, then my suggestion would be to go to MathsWatch and look at these 2 clips. Clip 118 to practice using the theorem to find the longest side and shortest side of triangles, or clip 119 to find the distance between 2 points on a graph. Hope you found this useful, and thank you for taking the time to go through it.